Hey guys, welcome back. Professor Doney here for another installment video just to help you through some of this physics here. What we're going to talk about today is one-dimensional motion, and we're talking about acceleration. Previously we defined acceleration as the little smaller as the change in velocity over the change in time, meaning how are we speeding up or slowing down every second or as time goes by. And that again has units of meters per second, which we can clean up to be meters per second squared. Alright, so in this example what we're going to do is have a car that is traveling initially at, let's say, about 30 meters per second. That's somewhere around 66 miles an hour, so you can think of that as you solve the problem. As it goes on, it's going to hit the brakes. It's eventually going to come to a stop. Alright, you're going to hit the brakes and slow down. If we're hitting the brakes, we're actually hitting the decelerator, called decel, and that would imply that our acceleration is actually negative because we're slowing down. Every second we're slowing down, going slower and slower. So we're expecting our answer to be a negative. So in this example, we have a car goes from 30 down to 0, and let's say it takes, I don't know, 6 seconds to do that. That's the change in time, delta t or just t. Now again, what we have is our three constant acceleration equations. What that means is they can be used for any problem involving motion where the acceleration is either a fixed number. The speed up rate is fixed, or the slow down rate, the deceleration rate is fixed. We cannot hit the nitrous, our turbo doesn't kick in, we can't downshift to go faster, rev the engine, anything like that. It's just once we start accelerating or decelerating, it is a fixed and constant rate. So again, our equations we have are these three. And again, the sub-zero just means that it is the initial or starting. Half at squared. Alright, so there's our three equations. Alright, let's go ahead and solve this. I'm going to pick a different color here just so it stands out a little bit for you, and see if we can make this a little better here. Alright, so what equation are we going to use? Well, we're trying to find acceleration. That's what we're asked the problem. Find the acceleration. We're expecting it to be a negative because it is slowing down. So what we need to do is look at these three equations. Now the brute force quick way is to underline what we're trying to find and then check all the things that we know. Do we know final velocity? Yeah, it comes to a stop, so I can check the v and everything. Do I know initial? Yeah, it's going at 30. I can check those. Do I know the time frame? Yeah, 6 seconds, so I'll check that. There's also another t there, there's another t there. What I don't know though is how far it took to stop. Car manufacturers may call this the stopping distance. This is really important when they're trying to sell minivans or Volvo type cars that are safe for the family. They want to know how quickly they can come to a stop, especially if there's an accident or something like that. So if we look at these three equations, the first one has one unknown, the second one has two unknowns, there's two underlined, and the last one has also two. Now to solve an equation that has two unknowns, we actually need two equations, so I can't use either the second or third. I have to use that first equation. So we're going to start with that. V equals VO plus AT. Our final velocity is 0. Our initial is 20 plus A, we don't know, and it's 6. Again, I'm not including units here just to keep it clean. If I've solved this, I'll put minus 20 on both sides, subtract 20 from both sides. I'm left with minus 20 is, oh, sorry, this would be a 30, shouldn't it? Somebody catch that? Because I started with 30 here, my bad. So minus 30 over 6, we divide that, we're going to get acceleration as minus 5 meters per second squared. Should we get a negative answer? Absolutely, we're slowing down. And since minus 5 meters per second squared is really minus 5 meters per second every second, if we count off 6 seconds, we'll come up with 30, 25, 20, 15, 10, 5, 0. That checks. Alright, I'm out of time here. Hope that helped. Look for more videos on my YouTube channel.